All right. So right now what you should have out in front of you is the worksheet. You should also have it out in front of you is the notes, page 11, which has example 4, where we factored out a trigonometric expression that's similar to this worksheet. And what you should also have out is the yellow Pythagorean identities organizer that I handed out to you and you took video notes on. What I have right here are the 3 Pythagorean identities, which is found on that yellow organizer that you should have out and you should be referencing. All right, so in order to do this task, I'm going to go ahead and talk about how I did this example that's on top of your worksheet. I went ahead and I rewrote the problem. Now, the first step I want to identify here is any common terms that I could pull out. So if I look at the first term right here, I notice there's a 2. I notice there's 2 tangents because there's a square here. I also notice in the second term there's a 2, and I notice there's 4 tangents because there's a 4th power. Then this 3 right here is by itself. This 3 does not appear to have any common factors with these previous 2. So first off, I notice right off the bat that I can pull out a 2 because 2 is in common to both of these 2 terms. Next up, I could pull out 2 tangents from here, and I can also pull out 2 tangents from here because this one has 4 tangents to offer. But what these 2 have in common are only 2 tangents. So I'm going to pull out 2 and tangent squared. Then I'm going to put in parentheses and I leave over what's left over inside. Because I pulled out this whole 2 tangent squared theta, what's left over is just 1. Let's make that clear. It's not going to be 0. It's going to be 1. All right. So I pulled out a 2 from here. So the 2's gone. And I pulled out 2 tangents from here. So what I'm left over with is 2 tangents. That's what's left over in the parentheses. This plus 3 was not involved, so I just leave it as plus 3. Great. Now at this point, now that I factored out the common factor, I have to use my Pythagorean identity. At this point, this is when I'm using my yellow organizer, which is right here for me. For you guys, you would be looking at your yellow paper. Inside the parentheses, 1 plus tangent squared, if I look at my organizer, 1 plus tangent squared is equal to secant squared. So basically, this stuff in parentheses right here is going to become secant squared in red. Okay. Now basically that's pretty much it. I don't see anything else I could simplify. So what I'm going to do in my next step is drop the parentheses and just make sure everything's in black. And basically we're done. We have simplified this trigonometric expression. As you can see, to simplify means it gets smaller. So it went from having 3 terms to now having 2. It looks more condensed and much more neater. Alright, so now that I explained to you how we do the examples, what I'm going to do is go over how to do number 1 and number 2 with you. Alright, so let's take a look at number 1. I went ahead and rewrote the equation here. And now I'm going to go ahead and take a look at my 2 terms. I only got 2 terms here. I notice there's a cosine theta here and there's also a cosine theta here. So basically what's in common to these 2 terms is just cosine theta. I'm just going to be pulling out 1 cosine theta, and in parentheses I'll leave over what's left over. Since this whole cosine theta came out, that's why you see a 1 right here, not a 0. And since cosine theta came out of this first term right here, you're just left over with cotangent theta. Alright, now from this, we're going to go ahead and take a look at my yellow organizer. I'm going to take a look at my Pythagorean identities list, and I'm going to see if the stuff in parentheses is equal to anything. And there we go. Cotangent squared theta plus 1 is equal to cosecant squared theta. So this stuff right here in parentheses is going to become cosecant squared theta, and that's going to appear in red. Alright, it looks like I'm done simplifying. What I'm going to do is drop my parentheses and put everything back to its original color, and you are done. We have simplified number 1. Let's take a look at number 2. Number 2, I notice again There's a cosine that's a common to the first term and also to the second. This one's pretty simple. I'm just going to go ahead and pull out cosine theta. What's left over in the inside is 1 plus tan squared theta. Awesome. Now my next step is I'm going to go ahead and take a look at my yellow organizer. 1 plus tangent squared theta is equal to secant squared theta. This right here inside the parentheses is going to become secant squared theta in red. Good. So it looks like I've simplified all that I can. I'm just going to go ahead and color code everything in black, and then I'll be done. For those of you who want to go ahead and push yourself in this thinking, you could simplify this even further. Think about what secant is with respect to cosine. If you look at your yellow organizer and try and see if you could simplify this further. But that's pretty much it. If you want to push yourself, I do push you to go ahead and simplify this further. Now I encourage you to go ahead and try the rest of these problems. Try to follow the steps to the best of your ability. And please make sure you reference your notes and use your resources.